We are continuing with rotational motion. Yeah, from where we ended, and we're just talking about the parameters that describe motion in a circle. And we're just talking about saying these parameters are, we have angular displacement, angular velocity, and angular acceleration. And what we see here on this circle is just an object moving in a circular path. And then if it moves, for example, a certain angle, that displacement will be recorded in radians. It will be recorded in radians. Its displacement will be recorded in radians, and then if it moves a certain angle in a certain period of time, then we'll call that the angular velocity, which will be in radians per second. So otherwise, if an object completes one revolution, if an object goes around this circle and completes one revolution, we're saying one revolution is equals to 2 pi radians, right? So this relationship should be understood. So usually we know, we are very familiar with angular or rotational motion. We know this is how if we want to find our if we want to find our angular displacement, we just we have an S here. This S is the distance, linear distance that has been moved. If you get the linear distance and then you divide it by the radius, you get yourself your angular displacement, and it should be in radians. And then we also know that if our angular displacement is changing with respect to time, so the change in angular displacement with respect to time is angular velocity, and it's recorded in radians per second. And then our acceleration is, if our angular velocity is changing with respect to time, it will be our rads per second squared. So obviously these concepts, you know them, but again, the other thing that we would need to say quickly, because I know these concepts you are very familiar with, but if you are still not familiar with these concepts, you can still ask me. But otherwise, since we have dealt with linear motion before, so you know parameters that describe an object in linear motion with a certain acceleration. We know that this formula can give us velocity, this formula can give us displacement, and this other formula, we have seen these formulas before. V squared is equals to initial velocity squared plus 2a and the change in displacement. So displacement has been given as x. So the interesting thing about this is that even in angular motion or rotational motion, these equations are still applicable. All right, only that they change this symbols. They change symbols, and of course they change meaning, but they are the same equations. We know that even in angular velocity we have, I mean, if we are in rotational motion, even in rotational motion, what will happen is same equations but different symbols. Here we are talking about angular velocity being angular velocity initial plus angular acceleration and times time. So even when you are doing your calculations, you can still use these same equations. If you want to find your angular displacement, you can still use equation which is analogous to that equation. So it is very easy for you to maneuver in rotational motion, because some of these equations which are there in linear motion apply to rotational motion, only that the signs, the symbols change. But even here in rotational motion, what you discover that these are vector values. Velocity, angular velocity is a vector, so it might be negative or positive. Acceleration, angular acceleration is a vector. It might be positive or negative. Even the angular displacement is a vector. And yeah, all these parameters that you see here, apart from time has no sign, it's not a vector, it's a scalar. So most of these components you see here will have vector components, and then they are vectors, and therefore you should be able to pay attention to their signs. And yeah, so one other important aspect that you need to remember is that when you are comparing, this is a parameter in linear motion, and this is a parameter in rotational motion. So this S is not speed, it is displacement or distance. All right, if you want to find distance given parameters in rotational motion, so you just get a change in the angular. This is angular displacement. You multiply it by the radius, you will get your displacement in linear motion. Again, even your velocity in linear motion, you get your angular velocity multiplied by the radius, you will do the interchanging. So this is one way in which you can move from linear motion to angular motion. Same as for acceleration, you just multiply the angular acceleration by its radius, you'll be able to get your linear acceleration. Are we together so far? Are we following so far?
Yes, sir. Yes.
What do the others who are quiet say? Are you following? The others seem awesome.
For me, the network is very bad. So,
oh, the network, huh?
Hard to get it. It's tripping.
Oh, okay. I understand, Mr. Wisdom. I wish there would be something we can do. But otherwise, even if it's not holding properly, try and get as little information as you can, so that since I'm recording, I'll post it on YouTube where you can actually watch freely at any time where your network will be able to hold properly. But otherwise, try to follow closely as possible. So I was just explaining a little about rotational motion, and yeah, this information mostly you know it, but what is most important is, given this information that you have, how do we analyze questions? Because sometimes questions, they don't just require you to just get a pen and a paper. Oh, I'm reading, I find some data, what is my equation, I put in the equation, I get the answer. It's not as easy as like that. And I always emphasize to you, my friends, I don't know how many times I'll say it, but if I need to say it again, I'll say it again. I would say that in physics, university physics, never, when you read a question, you get some data, you get equations and just start plugging in like that and then start solving. It's not usually as simple as that. Of course, there are some questions which are straightforward where you can put the equations, but mostly they are concept questions. And these concept questions will require you to think. And sometimes it may require you to visualize what is happening. And then that is how you are going to successfully answer questions in physics. So if a question comes, okay, you even have seen, okay, this is my initial velocity, this is my final velocity, this is my what, let me get a formula, I plug in. It usually doesn't work out like that. It would require you to think, and think. So you will discover that even this question that we're going to look at is not going to be just straightforward. It's not a complicated question, but it's requiring you to do a bit of some thinking. So we have a question here, and I would request that we have Florence read for us this question, and then we can move to solve it.
The question reads, a wheel of radius 25 centimeter has 8 spokes. It is mounted on a fixed axle and is rotating at a constant angular speed. You shoot a 20 centimeter long arrow parallel to the axle through the wheel at a speed of 6 meters per second. The arrow and the spokes are supposed to be thin. Calculate the maximum value of the angular speed in radians per second and in revolutions per second, so that the arrow just goes through without hitting any of the spokes. Does it matter where between the axle and the rim of the wheel you aim? If so, what is the best location?
Awesome. So we have a question there, friends. And so what are we getting from the question as we are reading? So we are getting a question where we have a wheel. Of course, as it has been drawn here, we have a wheel. And I can also even do a bit of some sketching here. We have a wheel of about 8 spokes, like that, and like that. So we have 8 spokes. And then I want to pass an arrow through these. I want to pass an arrow through these spokes. All right. So this one is rotating. Say it is rotating even in that direction. It doesn't matter which direction, but it's rotating. Say this wheel is rotating. All right. And we have been told that the radius of the wheel from there to there is about, so of course we know it's about 0.25 meters. This is the radius. And what other information have we been given here? We have been told we are shooting an arrow, all right, parallel to the axle through a wheel, through the wheel, okay, parallel to the axle of the wheel. In fact, this one's supposed to be axle of the wheel, so it is parallel to the axle of the wheel, and the wheel is this same arrow. So this same arrow that we are talking about, we shoot an arrow which is parallel to the axle of the wheel at 6 meters per second. So we shoot an arrow, as you can see in the diagram here. We shoot an arrow through this through these spokes. We shoot an arrow, and then this arrow should be 6 meters per second. That's the velocity of the arrow. So while this wheel is rotating, all right, while this wheel is rotating, we shoot an arrow. The idea is we don't want this arrow to hit any of the spokes. We want this arrow, which is of a distance, the length of the arrow is 20 centimeters. That's the length of the arrow. So as it will be moving through these spokes, this wheel will be rotating, all right? So high chances are there that the arrow and the wheel will bump into each other. But we want to shoot at a speed where this doesn't happen, where the arrow just passes through properly. Okay, are we following the explanation? Are we following the explanation?
Yes, sir.
Awesome. So I would,
Yes, sir.
yeah, wonderful. So yeah, so that's the information. And I've realized that some of you guys will tell me that one of the challenges that you have in physics is probably trying to understand what actually the question is saying. and then how are you going to use the equations? All right. So what is the question? What the question is saying is just a general understanding. What the question is saying is you have a wheel with 8 spokes. You want to shoot an arrow to pass through this wheel, through these spokes. Now, we have been given the speed of the arrow and the length of the arrow. At what maximum speed? All right, what maximum speed? Because at a certain speed, this arrow will no longer be able to manage to pass through without hitting the spokes. But at a certain speed, it will be able to hit. All right, at what maximum speed will the wheel be rotating at so that the arrow can pass through it properly? So now, certain things have to start poking your brains when you hear a question like that. All right, certain information has to be hitting you, certain triggers. You should now start seeing how you can relate the speed of the arrow to the speed of the wheel, because we are talking about, hello? Someone has a question? Okay, welcome late Precious. Precious, you are late. You are late. Late, yes, not late. Yeah, you are late, but hopefully.
Busy. I was busy.
Oh, okay. Awesome. Hopefully you can be able to follow through. And if not, then you can be able to also watch the video so that you can be able to follow through. Otherwise, hope you are having a wonderful afternoon, and hope you can manage to follow through. Is that okay? Awesome. So I'm saying, hope you are fine. Hope you are fine, and hope you.
Yes,
I'm good. I'm good as well. I'm good. So, where were we? I was explaining this question. Okay. So, for the sake of our friend Precious who has come through, I'll just read this question one last time, and then we see how we can start solving. So, we have a question which is talking about a wheel of radius 25 centimeters. And this wheel of radius 25 centimeters has 8 spokes, and it is mounted on a fixed axle which is rotating at a constant angular velocity. So the wheel is rotating at a constant angular velocity. Then you shoot an arrow of you shoot a 20 centimeter long arrow parallel to the axle of the wheel at a speed of 6 meters per second. The arrow and the spokes are to be thin. All right, the thinness is that so that we can neglect the thickness of the arrow and the spokes. So calculate the maximum speed, calculate the maximum value of the omega, which is angular velocity in radians and in revolutions, so that the arrow just goes through without hitting any of the spokes. And does it matter where you actually throw the arrow? So now the idea which I was trying to mention to you guys is that you need to now relate the two. You need to relate, when we look at the data, we have been given the radius of the arrow, the radius of the wheel, and we have been given the length of the arrow. So it's the one which I've indicated as D of the arrow. We've been given the velocity of the arrow. All right, we've been given the velocity of the arrow. We have also been given the velocity of the wheel. We don't know, but we've been given the number of spokes. How do we relate the two information? Now, one thing that I would like you guys to be doing is you have to be thinking analytically and relationally. you have to be able to see, okay, I have my arrow, all right, which is about 0.2 meters, all right. So as it will be passing through, as my arrow will be passing through this wheel, all right, the arrow will need to pass, the whole lot of its length will need to pass through these spokes, all right. So in a particular, between two successive spokes, this arrow would have to pass like that. And what can I do to relate the information? So I know that my arrow will need to pass through the spoke. Since the arrow, the speed is 6 meters per second, then I will need to realize that what relates the speed of the arrow. So we are just talking about the arrow first of all, the speed of the arrow and its length. So given the speed of the arrow and its length, what relates them is the time, all right? So the time it will take for the length of the arrow to pass through. To pass through will be related by like that. The time it will take for the length, or should I say the distance of the arrow to pass through given the speed at which it is moving at. It is moving at 6 meters per second. So the whole lot of its length for it to pass through, it will have a certain time. There will be a certain time that will elapse. Now that same time should also be able to relate with, I should also relate that time with the wheel as it is moving, all right, the wheel as it is moving. So for the wheel, for this spoke to move from this position to go to this other position, there will be a certain distance that it will move, all right? There will be a certain distance when the wheel will be rotating. The meeting is about to end, but you go back to the link so that you can come back to this meeting. Google has Zoom has told me that we have very little time remaining, but you go back to the link so we can continue. But yeah, I was talking about the relationship between the two, and then so I guess let me end here. But then when the meeting comes, then we'll continue talking